Hi, we're going to look at scatter plots today. So a scatter plot is like a really messed up line. Um, Usually when we're dealing with linear functions, we're dealing with uh, x's and y's that form a straight line. When we're dealing with a scatter plot, we have a bunch of data that doesn't necessarily fit on one line, but it fits in a general trend. And that's what we're going to look at today. So before we get into anything fancy, let's look at different trends and we call them something special. Instead of saying like a slope or just a linear line, we tend to use the word correlation. Now, correlation means just your general trend, your relationship between all these points. Now, if we go back to slope, we have positive slopes, negative slopes, all that. I still want to kind of look at my general direction that all of my points are moving. So if I look at this, I can see that if I were to like zoom out, I'd kind of have a really blurry kind of line going in that direction. Well, if we go back and we read our book or read our line, we always want to go left to right. Do you go uphill or downhill? We're going up. Since we go up, we then say that's a positive slope, or in this case, positive correlation. Same thing works in the reverse. So the general trend of our lines happen to be going in this downward fashion. So when we read this graph, we're going downhill, which means negative slope or negative correlation, the general trend of all the dots, all of our coordinates. Now, let's just say we happen to have like a random point way over here or up here somewhere like that. Sometimes if everything's condensed enough and then you got this one little weirdo kind of out of nowhere, we call that an outlier and we can sometimes just ignore that. But outlier, that is, it's just some weird point out in the middle of nowhere. Now, what happens if we have a set of data that doesn't necessarily look like it really fits a line? We've got points all over. When it's all jumbled up and it doesn't really paint a little like picture of a line anywhere, we say it has no correlation or like no relationship. There's nothing tying them together. Okay, so correlation just describes the trend of our coordinates. We sometimes want to be a little more specific and say, well, I know I see a trend, I see this line. What is maybe the equation of that line? And we can say it's kind of in the middle of everything, and that line is called the line of best fit. We can use that. We can draw a line, we can write an equation, we could find the slope, find the intercepts, all that. And it tells us so much more information further from that. But let's try and find the line given all this information. Now, how do you find the line of a scatter plot? Because I could connect all different types of dots. I don't want to just connect random dots. So first off, I got a list here, all our rules. First thing, plot coordinates. We already have them plotted. Good. Step one done. Step two, draw a blob. Super mathematically, I know, but we're going to draw a blob. What that means is I just want to make a big oval around everything, trying to encompass all of our points. There's your blob. Now, can you cut the blob in half? And I don't want to cut it this way because my line doesn't go that way. I want to cut it this way. So again, let's forget about all those coordinates that are already there. I just want to care about my blob. And I want to draw a line as best as I could through it. Okay, so plotted, drew a blob, cut the blob in half. Now, we need to figure out what our slope and what our intercept is. Now, there's tons of different things I can do to get here. Well, slope, you could find 2 points. You could use your slope formula, m equals y2 minus y1 divided by x2 minus x1. Or we could go back to the whole rise over run thing. Um, Forget about all the black dots. Let's look at the purple. Purple's the only thing that matters right now. I want to find any coordinate that I can read nice and easily. So I can read that nice and easily. I can read that nice and easily. I can read that nice and easily. Um, Okay, now I know my line's a little sloppy. It's not the best line, but I do have some really good information here. One being this purple line crosses the y-intercept, or crosses the y-axis, giving us a y-intercept. I know what b is. B is going to be, in this case, -1. Now I need to find slope. Uh, Best way to find slope, let's just count rise over run. Um, I could go from here to here, but I'm actually just going to go from one end all the way to the other. So let's count our rising. 1, 2, 3, 4, 5, 6, 7, 8. So we rose 8. And then we go over 1, 2, 3, 4, 5, 6. I don't want to leave my slope like that. I want to simplify it, which cut everything in half to both even numbers, 4 over 3. There's your new slope. So we have b, we have m, we found m and b. Can you write the equation now? Sure. Y equals 4/3 x minus 1. Where did I get that from? Well, y equals mx plus b. Now, with this equation, we can find a couple other things. Um, I could pick a point somewhere in the middle of this graph. So if I said x was 3, 1, 2, 3, I want to figure out what y is. Now, I know my graph's a little sloppy. Let's see if this works. So if I said 3, what's my matching y? So it should be almost 3, a little under 3. So if I put 3 in there, my 3's would cancel out. Let's see if I can do this. Y equals 4/3 times 3 minus 1. Those are gone. 4 minus 1. So if I were to take 3 and plug it in, I want to find out what my matching y value is. And in this case, I'm getting 3. Is this about 1, 2, 3 would be right there. I get a sloppy graph. Maybe it would be better if it wasn't on a whiteboard. But yeah, this right here, we can predict what numbers are in the middle. We could go further and predict numbers outside of this graph if we wanted to. So our graph goes up to 3, 4, 5, 6, 7. If I did 12, I could pick 12. And then I want to figure out, what do we match up there? If I put 12 in here, let's switch this up. 3 and 12 cancel. That's a 1. That's a 4. That's 16 minus 1. Y would be 15. Yeah, so if we went all the way over to 12, we go up. We'd match at y equals 15. Is it really all that important? Not unless we're being asked. What do we care about right now? Correlations, positive, negative, none. Plot, blob, cut in half. What's m and b? Write the equation. That's what I need right there. That is finding scatter plots.